Good afternoon.
Good afternoon, Mark.
So my name is Marek Pawlicki, and I have the pleasure to be here and to present the UTP University of Science and Technology in Bydgoszcz, Poland. In the following slides, I'll focus on how we provide a machine learning-based network intrusion detection. So now, if you're like me, you like to know who is authoring the work just as much as what the work is about. So we are a research group called InfraStress, based at the UTP University. The group consists of Professor Michał Horaś and Professor Rafał Kozik, who are the founding members, supported by in InfraStress by Bydgoszczy, Mikołaj Komisarek, myself, and a list of other researchers and software developers. We have experience in a range of EU-funded projects, starting from Framework Program 6 through 7, Horizons, and also, for example, projects funded by the European Defence Agency and NATO. Our main interests are in machine learning and pattern recognition, data mining and data analysis, and the practical application of those, usually in cybersecurity. So to give you a good high-level overview of the work we do in InfraStress, we're taking network traffic, process it, put it through the machine learning models, and we end up with a classification indicating if the models think that the traffic resembles benign traffic or does it look like some kind of attack. Now, each of those blocks represents some important decisions that we had to make during research and development. For network traffic, do we do deep packet inspection, or do we take net flow-like data, like NetFlow? How to achieve scalability of stream processing? What machine learning algorithms do we use? What are the pros and cons of those algorithms? How we can make them better suited for intrusion detection, and so on and so forth. During the project, we did plenty of research to adequately address those questions. As you will see in the video demonstration I intend to show you in just a few seconds. And we've built a piece of software that uses NetFlow data. We've developed the solution in a modular manner, so we can easily implement machine learning algorithms coming from different ML libraries. This allows us to leverage the whole machine learning pipeline. So we can not only do classification, taking advantage of, for example, TensorFlow, but we can handle things like data preparation, retraining the models, etc., etc. During the development of the solution, one of the aspects that we've put the most importance on was processing large amounts of data delivered by the stream. So in order to avoid problems with performance and achieve adequate scalability, the model executing the reception of and preprocessing of the incoming data is developed in Scala and based on Apache Spark. This facilitates the scalability of the solution, which has the ability of utilizing multiple Spark workers and splitting tasks into different servers. Now, we've also spent quite some time trying to push machine learning to get better results. The results of some of this work have been published in scientific journals and conferences. For me personally, it's always a good news to see that the results of your work are accepted by the scientific community. Now, I'd like to show you a short video which includes some more details about the machine learning based intrusion detection solution, a demonstration of integration with DPS in the InfraStress Pilot 2, and a brief preview of the tool dashboard.
This is the demonstration.
Yes.
STCD2 InfraStress component developed in the project by the UTP University of Science and Technology in Bydgoszcz. The STCD2 component realizes one of the cybersecurity measures of InfraStress. The component uses streamed NetFlow data transported via Apache Kafka in conjunction with machine learning algorithms to perform real-time detection. The results obtained by this process are then gathered in an informative dashboard. The details of each bit of that process will be explained in the following demonstration. The use of Apache Kafka ensures a number of benefits, including quick scalability. The process of consuming NetFlow data directly from the stream is now displayed on the screen. Using NetFlow data grants an immensely effective high-level view of the network. The STCD2 component can work with both NetFlow version 5 and version 9. Machine learning in STCD2 utilizes state-of-the-art models built using the industry-standard TensorFlow technology stack. The details of the detection models can be found in recent U2P scientific publications acknowledging InfraStress. The processed frames, along with their classification labels, are forwarded using Kafka to the Elasticsearch database and further used to provide the human operators an informative dashboard. The dashboard contains items like suspicious frames table, an indicator of the number of all collected NetFlow frames, a counter for all detected anomalies, a counter of clean traffic, a plot of traffic classification, the amount of data sent by individual hosts, how many anomalies were detected per individual host, and a breakdown of anomalous and normal traffic in time.
Now, InfraStress adopts a user-driven approach, with the technical activities driven by and receiving feedback from the end users of the system. We have 5 pilots in the project. The machine learning-based intrusion detection system, developed by U2P University, is one of the cybersecurity measures implemented in Pilot 2. Pilot 2 is about securing medical device manufacturing and supply chain, and the partner piloting the InfraStress components is based at the Puy-Synthes medical service manufacturing site on the shores of the Cork Harbour, just outside the Cork city in Ireland. And DPS is using the UTP solution for cybersecurity. What you're about to hear is part of our recording of a test session we have performed in Pilot 2.
Okay, so I propose that we jump right in. So maybe let's show how it works from your perspective, and then I'll show the dashboard of the STCD2 component.
It seems that from my side that this is working as expected, which is great. So here we have the event that occurred, and then we have the generation. And then here we have the mitigation that has been generated. The most important part is this event ID that I have here, and then it's the same event ID that I'm responding. So then from the CM side, the event ID should be on the top, I think, yes. So this will be this 36 something. And this is the same ID. So now I can see that there's Okiro, and then there is the message with the mitigation, right?
Yes, and the first part of this loop is provided by the U2P component. That's the intrusion detection.
This is
Okay, So to wrap up, if you find this interesting and you like this presentation, I'll stick around to the end of the session to answer your questions. But you can also reach me via this email, marek.pawlicki@utp.edu.pl. And it was a pleasure and an honor to present to you today.